Welcome to our video lesson on security design principles. In this session, we will delve into essential concepts that form the foundation of secure software development. We'll cover system tenets, secure design principles, security models, and the types of adversaries that threaten software security. Let's get started. Part 1. System tenets. First, let's discuss session management. This involves managing user sessions to ensure secure and efficient communication between system components. It's crucial to establish secure session initiation, maintenance, and termination protocols to prevent session hijacking and fixation. Next, we have exception management, which is all about handling unexpected conditions and errors in a secure manner. It's important to ensure that errors do not leak sensitive information and that the system remains stable and secure during failure states. Configuration management is another critical aspect. This involves controlling and managing configuration settings to maintain system security. It's essential to use change control boards and workflow systems to manage configurations effectively, and to separate duties between production and development to prevent unauthorized changes. Secure design tenets. Let's move on to secure design tenets. One key principle is good enough security. Security must be appropriate for the value of the protected assets, balancing security measures with system performance and usability, and avoiding over-securing low-value assets. Another fundamental principle is least privilege, which means providing the minimum level of access necessary for a user to perform their tasks. This reduces potential damage from compromised accounts and is often implemented through role-based access controls. Separation of duties is essential to ensure that critical tasks require multiple approvals. This approach prevents fraud and errors by implementing checks and balances in system processes. Defense in depth is a strategy that uses multiple layers of security to protect assets. Combining different security measures provides comprehensive protection, incorporating both physical and logical security controls. The fail-safe principle ensures that systems remain secure even when they fail. Systems should be designed to default to a secure state during failures, using explicit deny mechanisms to prevent unauthorized access. Economy of mechanism is about keeping security mechanisms simple to reduce vulnerabilities. Simplified code minimizes potential security flaws and makes security mechanisms easier to understand and manage. Complete mediation requires verifying every access request to resources. Thorough access control checks prevent the circumvention of security controls. Open design is the principle that security should not depend on the secrecy of design or implementation. Security should rely on well-tested and publicly vetted algorithms, ensuring it depends on secret keys, not secret algorithms. The least common mechanism principle aims to minimize the sharing of mechanisms among users to prevent unintended interactions. Designing separate mechanisms for different user levels avoids shared resources that could lead to information leakage. Psychological acceptability ensures that security measures are user-friendly and do not hinder usability. Security features should be transparent to users, much like air invisible yet always present. Addressing the weakest link is crucial, as a system is only as strong as its weakest point. Identifying and reinforcing vulnerable areas continuously is vital for improving security measures. Leveraging existing components involves reusing well-tested components to reduce vulnerabilities. This minimizes the introduction of new, untested code and benefits from the security of established components. Finally, avoiding single points of failure is imperative. Ensure redundancy and failover mechanisms are in place, and regularly test and validate failover processes to maintain system security. Security models. Now, let's discuss security models. Access control models are used to define what actions a subject can perform on specific objects. There are several models, including mandatory access control MAC, discretionary access control DAC, role-based access control RBAC, and rule-based access control also RBAC. Each model provides different levels of control and flexibility, and it's important to choose the model that best fits your security needs and organizational policies. The multi-level security model enforces policies based on different levels of sensitivity and clearance. This model ensures that users can only access information appropriate to their clearance level, preventing information flow from higher to lower security levels. Integrity models, such as the Biba and Clark-Wilson models, focus on maintaining data integrity. These models prevent unauthorized modification of data and ensure that data remains accurate and reliable. Information flow models manage how information flows within a system. Controlling and monitoring data movement helps prevent leaks and ensures that policies restrict data flow based on security requirements. Adversary. Finally, let's talk about adversaries. Adversaries come in various types, each with different motivations and techniques. Individual hackers, hacktivists, nation-states, and criminal organizations all pose unique threats that require specific defensive strategies. Adversaries can also be grouped based on their level of organization and resources. Unstructured threats typically involve individuals or groups with limited skills and resources. Structured threats are more organized and can commit significant time and energy to an attack. Highly structured threats have even greater resources, such as criminal organizations that employ teams of programmers to develop sophisticated attack tools. Nation-state threats are the most resource-intensive and often involve advanced persistent threats apps that can penetrate networks and remain undetected for long periods. These threats are usually aimed at government-related entities, and defending against them requires significant resources. It's also important to consider the insider vs. outsider threat distinction. Insiders have legitimate access to a system and can exploit their knowledge of the system to launch attacks. A comprehensive security solution must monitor for both external and internal threats to be effective. Understanding and applying these security design principles is crucial for developing robust and secure software systems. By integrating these concepts into your development process, you can significantly enhance the security posture of your applications and protect against various threats. Thank you for joining this lesson, and we hope you now have a solid foundation in security design principles.